Hello friends, welcome you all to the new online course on ARM processors. In this course, we will discuss and understand the various ARM processors, their architectures, their significance and popularity in the market. At the beginning, we will understand what is the importance of ARM processors, or we will discuss why we consider ARM processors study or what is its importance. So when you consider why the student has to understand the ARM processors and its architecture, ARM processors have extensive applications in consumer electronic devices such as smartphones, tablets, multimedia players, and other mobile devices such as wearables, wearable watches, etc. ARM remains at the center of smartphone evolution, with more than 95% of the world's smartphones built on ARM's IP, means intellectual property. ARM's IP designs for smartphones enable the most popular ML-based, machine learning-based real-world applications. ARM version 7 and ARM version 8 are the most recent and popular processors used today. ARM allowed smartphone manufacturers like Qualcomm, Nvidia, and Apple, etc. to design their own CPU cores. For example, the very recent mobile phone Redmi 9, most of you might have heard about this, is powered by octa-core 2 GHz dual-core ARM Cortex A75 plus 2 GHz hexa-core ARM Cortex A55 processors. Actually, this Cortex is an ARM processor, basically. Cortex A75, Cortex A55. Students who are interested, just they can go to the settings and there you find about your device. There you find this information. Similarly, the Oppo Reno 2F, this is also a recent smartphone. If you see, it is powered by an octa-core 4 by 2.1 GHz ARM Cortex A73 and 2 GHz ARM Cortex A53 processors. So undoubtedly you can say that these ARM processors play a very important role in the present day smartphone market. Almost majority of the present day smartphones or mobiles use these ARM processors. Of course, you may understand in future that this ARM is not as a single chip but as SoC. Very soon I'll make one more video about this SoC concept. So whatever it may be, the ARM has a very important role or important part in the present day mobile market or smartphone market or consumer electronics domain. Not only the mobile market, recently Apple announced its first homegrown ARM CPU intended for desktop and laptop computing applications also. You may have a doubt that these ARM processors are used only for mobile or smartphones. No, they are also used in desktop and laptop applications also. Now, let us understand what is this ARM processor. I have not explained to you what is this ARM processor. First, I have explained to you where the ARM processors are present, what is its use. Now let us come to the introduction of ARM processor. Actually, the ARM processor was originally designed at Acorn Computers Limited of Cambridge, England during the year 1983-85. Acorn Computers Limited. It was the first RISC microprocessor developed for commercial use and has some significant differences from subsequent RISC architectures also. What is this RISC? Reduced instruction set computer. Reduced instruction set computers. Normal Intel processors, all the Intel processors, or majority of the Intel processors are CISC processors, complex instruction set computers. So these are all RISC processors, all the ARM RISC microprocessors. Then what is the story behind this? Let us go further. In 1990, actually, ARM Limited was established as a separate company specifically to widen the exploitation of ARM technology. What is ARM technology? Advanced RISC machines. ARM means advanced RISC machine, where again the RISC stands for reduced instruction set computer. So in 1990, ARM Limited was established as a separate company specifically to widen the exploitation of, to use to the maximum extent the advantages of the ARM technology. And very soon it is established as a leader in the market for especially low power and cost sensitive embedded applications. Very soon it has proved itself that it is mainly intended for low power and cost sensitive embedded applications. Later, this ARM company has changed its name as ARM Holdings. This is of course a commercial aspect which we don't require. Now, once you understand ARM, many people will be, or many students will be under the impression that ARM company is manufacturing or fabricating this microprocessor. Absolutely no. This is the most interesting point. That's why, in fact, ARM does not fabricate. Fab means fabricate the microprocessor. It is basically an IP company, that is intellectual property company. That means it designs the system, ARM system or ARM processor, and gives licenses to the other companies like Intel, Texas, Samsung, Qualcomm, and so many other companies. These companies will purchase these licenses and fabricate the chips. Very, very, very important, because your normal books do not mention these things. ARM is not a fabricating or fab company. It is basically an IP company. Of course, recently ARM has also entered into fabrication, but majority of the ARM processors here, it has given earlier, they have given only an IP licenses. So that means they will design a processor, ARM processor, and give licenses to these fab companies or core companies, and these companies will design or will manufacture the chips. Most important, though this ARM is a very, very big, people say semiconductor company, it won't fabricate any chip, it won't deliver any chip except the recent advancements. So the basic reason behind the origin of ARM processor. Then the question is, why these ARM processors were designed by this ARM company? During the time 1983 to 85, during those days, majority of the processors were Intel processors. And these, as I have told you, these processors are mainly 16-bit CISC processors. These CISC processors, complex instruction set computer processors. So the CISC processors were not of very high speed. Actually, they were slower than the standard memory parts available in those days. Therefore, these processors were not of great use in the market. And also, the CISC instructions used to take many clock cycles, that means more time. In some cases, many hundreds of clock cycles. Thereby what happens? The processor will become slow, which is otherwise called as long interrupt latencies. So for some operations, it may have to wait for hundreds of clock cycles also. Therefore, the market then realized that a processor of very high speed or high performance is required. So the result is your ARM processor. So advanced RISC machines, again I repeat, or RISC means reduced instruction set computer. So the ARM processor is supported by a toolkit which includes an instruction set emulator for hardware modeling and software testing and benchmarking, an assembler, C and C++ compilers, a linker, and a symbolic debugger. All this, it is a pack or a suit, you can say. So the ARM processor, when the companies takes the license from this ARM holdings, all these things are provided along with this processor. Let us go further to understand some more interesting things. So ARM is not a fab company. It should be clear, all the students, it should be clear that ARM is not a fab company. It only gives licenses to companies which manufacture ARM based CPUs or system on chip products, SoC, system on chip products. The architecture license, once a company takes the license for architecture, it enables the licensee, that is that company, to develop their own processors compliant with ARM ISA. ARM ISA means instruction set architecture. That is the most important thing, which makes the ARM suitable for low power embedded systems with high performance. We shall see these things only. Please remember, in this video I am not going to discuss the routine registers present in the ARM processor, number of instructions, and all these things. We shall understand or try to understand the secrets of this ARM processor architecture, which makes them a good candidate for embedded design. What are those features which makes this ARM processor suitable for embedded systems or using in smartphones or even laptops or desktops, etc. What are those interesting things? So for that only I consider the architectural features. So to understand the architectural features of ARM processors, let us consider the popular, academically popular in majority of the syllabus or in colleges. Students consider this ARM 7TDMI, which is popularly known as ARM 7. So we'll consider this as an example. Let us see. Let us start. So before I consider, first let us say what is this ARM 7TDMI. For this we have to consider ARM family. When you see this simple table, in the early days, ARM version 1 family, ARM version 1 was almost ARM 1. ARM version 2, then it has raised ARM 2 and ARM 3, ARM 3 and ARM 2. Similarly, version 3, ARM 6 and ARM 7. ARM version 4, it was strong ARM, one family, ARM 7 TDMI, another family, ARM 9 TDMI, another family. ARM version 5, it includes ARM 7EJ, ARM 9, ARM 10. ARM version 6 is ARM 11. So ARM 11 is not ARM 11 version, it is ARM version 6. After ARM 11, the company has changed the name or nomenclature to Cortex. I will discuss this in the next slide. So first let us understand. Therefore, what is our ARM 7 TDMI? ARM 7 TDMI processor belongs to ARM version 4. This information is very important for the beginners. So of course this ARM version 1, 2, 3, almost they are obsolete, outdated. We don't bother about these things. Normally we start from ARM 7 TDMI. Let us see what is the meaning of this ARM 7 TDMI in detail and try to understand the other important information related to this. Of course, after ARM 11 I have told you Cortex. Actually Cortex is a, normally it is used in by biology people. Why Cortex? Many students ask, because the textbooks will not cover such things. So what is the meaning of this cortex? Depending on the structure of the processor, that is a layered structure. For example, when you consider the brain, etc., the anatomy or zoology, these people, they call this as cortices or cortex. So this also, when they have taken the design, it used to consist of some layers, a layered design. Therefore, ARM has given the name cortex after ARM11. These cortex processors are three types, or three categories. Cortex A, which is called cortex applications, cortex M, cortex microcontroller category, cortex R, cortex real-time category or domain. So three domains are three sections. Cortex has been divided into three sections or three categories: cortex A, cortex M, cortex R. So after ARM7, ARM9, ARM11, in between 8 and 10 were not popular. So ARM7 is very popular, ARM9 is also very popular, ARM11 is very popular. After the ARM11 processor, we consider the cortex processors, cortex A, cortex M, cortex R. What are these? Cortex A, cortex M. Cortex A means cortex application. So this finds application in mobile phones as SOC, in the form of SOC, I have told you. So cortex M means cortex microcontroller. For example, the low power cortex M0 series is used in Arduino Nano IoT board. Most of the students may be familiar with Arduino boards, but many of you may not be in a position to say what is the microprocessor controller in the Arduino board. They say, many people say Arduino controller. No, it is cortex M0 processor or controller. Similarly, most of you might have heard about this Raspberry Pi board, very popular, started by BBC England. So this contains ARM11 processors. So all these things belongs to ARM-M microcontroller. Then cortex R. What is this cortex R? Cortex real-time applications, especially they are used for optimized for real-time and safety critical applications, especially in image processing or DSP applications, etc. This cortex R processor is used. Cortex M means cortex microcontroller. Cortex A means we have already seen cortex A53, A57. Most of the mobile phones, smartphones, laptops, they use this cortex A. Let us come to our topic, ARM7 TDMIS. The students first must understand what is the meaning of ARM. First, ARM, advanced risk mission. 7, it denotes the family, as I have told you, but version is 4. Version 4, but family is 7. Then what is this T? Let us start from the first one. ARM7 TDMI was introduced in 1995. The ARM7 TDMIS processor is a member of ARM family of general purpose 32-bit microprocessor. Then what is this T? T denotes thumb mode. You can select this, either the thumb mode or ARM mode. ARM processor will work in two modes. ARM mode means it is a 32-bit processor. ARM T thumb mode means it is a 16-bit instruction support. Why? Because when ARM was designed as a 32-bit processor, the market found that some of the smaller applications, they don't require this 32-bit microprocessor. That is the specialty of ARM. So they can use, because they give only licenses. That's why by paying lesser amount for smaller devices, that is where high performance is not required, where less memory is used, where 16-bit instruction set is sufficient, then they can use the same ARM processor in the thumb mode as a 16-bit processor, because all the instructions will be of 16-bit. But remember, the processor is same. It has that feature. This we will understand in the next coming videos by selecting the T-bit mode. So this may, when it is the bit is selected as 1, it will become the thumb mode. Otherwise, it is the ARM mode. ARM mode means 32-bit processor. Thumb mode means 16-bit. This is the specialty. Next, what's the on-chip debug support? A debugger is required. To check a program, we debug the program. To check the errors in a program, we debug it. So an on-chip debug support is provided so that the bugs can be eliminated. This is another very important concept. So what it will do, it will enable the processor to halt in response to a debug request. Whenever the user wish to debug the program, then the execution will be stopped. Halt means stopped, and the debug process takes place. This is on chip. That's why D indicates on chip debug support. M means enhanced or fast multiplier. Normally, multiplier is a very important concept in any processor. Why? Because it takes more time. One of the instructions which takes more time or more cycles is your multiplier when compared to addition or subtraction, etc. Multiplier takes more number of clock cycles. That's why in order to improve the performance, they have designed an enhanced or fast multiplier in the architecture. That's why M indicates fast multiplier, which yields a full 64-bit result. That is a high performance. Next, the MI. I means in-circuit emulator. So the embedded ICE macro cell consists of on-chip logic to support debug operations or emulation. So that is in-circuit emulator. What is this meaning of emulation? It is called mimic. So that means it will behave, it will show the result as if it is acting as a particular device. So that is emulation. So this emulator is provided on chip. Emulator is also provided so that the performance or the faults or the errors can be easily estimated or found without the help of external emulator circuit. Normally emulator circuits will be external, but this processor provides an on-chip emulator. That is the another most important feature. So the last one is yes. What is the meaning of this yes? Yes means synthesizable. What do you mean by the synthesizable? That means ARM7TDMIS. So majority of the textbooks will not cover what is the meaning of this synthesizable yes. So what is the meaning? Those students who are familiar with the VLSI, you might have come across a word called synthesis. Actually, what is the story behind this? When ARM started giving licenses, in the early days, they used to give only the hard macros only. That is the physical design at the transistor layout level. And the fab companies which I have told, whether Intel or Samsung or any people, so they take this physical design, physical block, and used to place it into their chip designs directly. But this was not configurable, this physical design. So when they want to configure or when they want to modify or do some changes, it was a very risky or cumbersome process. Therefore, these people started asking for a synthesizable license. So to overcome this complexity after a continuous demand from the companies, what ARM has done, ARM has decided to deliver processor designs as a behavioral description, that is the RTL written in a hardware description language, especially Verilog HDL. So using Verilog HDL, they write this behavioral code at the RTL model. So this will be synthesized. What is advantage? Then the manufacturers will convert this in behavioral description into physical network of logic gates, and this process is normally called synthesis. Therefore, these companies or the ARM company added a new word at the end, yes. That means they started telling that, or they started selling their licenses under ARM7TDMIS. That means the license they give is synthesizable. That is the advantage for manufacturers. But the student should also know what is the meaning of yes, why the yes is being used here. So now the entire thing is clear. ARM7TDMIS. So majority of the syllabus or majority of the courses start with ARM7TDMIS, which is popularly known as ARM7 microprocessor or microcontroller. Any word you can use. Now, I thought of considering this slide because the student should know who is the first designer of this ARM. She is Sophie Wilson in 1980s with his colleague Steve Ferber. This Steve Ferber is a very popular, that is the author of a very popular book, ARM System on Chip Architecture. Some of the students might have heard, or your teachers might have heard, or you can also go through the web and you can find this book. Very, very good, popular book. So, ARM System on Chip Architecture. So, the author is Steve Ferber, who has assisted this famous engineer Sophie Wilson. She is the designer of ARM processor. Actually, she is the most unsung engineer because no book or no material, no textbook will cover her name. So, just I want to give the students, or I thought that every student should know who is the designer of this ARM processor. When she was working with Acorn during 80s, so she first designed this ARM processor. So Sophie Wilson, here I am showing her diagram also. In this diagram I am showing her photo. So she is the designer of this ARM processor. So the credit must be given to her. Now what we try to understand here is, I have told many things about the ARM processor, or their importance, or their greatness. But for this high performance of this, the most important features, or what are the most important features which made it so popular? So we'll understand these novel, new, special features which made it possible. ARM has many special features that made them most suitable in embedded design. Now let us understand what is the reason for its high performance. Normally, as an engineer, you should know that the performance of a processor is mainly decided by two factors. Number one is the operational frequency or clock frequency. The other is its architecture, the architecture of the processor. Of course, when I say architecture, means it is both hardware architecture as well as software architecture. That is ISA, instruction set architecture, also play a very important role in deciding the performance. But when I consider the clock frequency, no doubt nowadays we are increasing market has increased the clock frequency. The manufacturers are increasing the clock frequency up to 3 GHz. As you know, either Intel processors or ARM processors, when you consider ARM Cortex A75 or 72, their operational frequencies have gone up to 3 GHz. But for this operational frequency, there is always a limitation. Why? Because as you increase the clock frequency, the power dissipation also increases. The chip will dissipate huge amount of power. This huge amount of power dissipation will change or will obstruct or will become a limitation for the performance of the processor. So the designer cannot go on increasing the operational frequency perpetually. That is the major limitation, because power dissipation is always proportional to the operating frequency. Therefore, on what factors you have to depend? We have to depend mainly architectural features. Now what we do is, we will try to understand those important features which make this ARM most suitable for many embedded applications. So what is this ARM architecture? Now let us consider. The designers opted a novel design architectures. What is that? Number one, ARM is basically a RISC architecture processor. What is that? Reduced instruction set computer. What are the interesting features of this RISC architecture? Number one, a load store architecture is used. That means only load store instructions can access memory, because as you know, the RISC architecture will have very few instructions which access the memory. Majority of the instructions will be registered based instructions. Why? When the processor try to access the memory, as you know, it takes more time. When you consider the three important things like your secondary memory, hard disk, primary memory like SRAM, and register or register file, we know that to access the hard disk, it takes the time of the order milliseconds. When we try to access the Memory like, what is this memory? SRAM, DRAM, etc. Semiconductor memories, it takes of the order of microseconds. But when you try to access registers or register file, it takes in nanoseconds. That means registers can be accessed at a very faster rate. That's why, in order not to use more memory related instructions, it uses only load and store instructions, very limited instructions. That means memory access instructions are very few in the case of RISC architecture. That means the speed is automatically improved or power dissipation is reduced. That's the most important. Remember, whenever we say ARM architecture means or RISC architecture means, the first thing is load store architecture. Only two instructions, load and store instructions, are available to access the memory. Whereas in the normal CISC, you will have more number of addressing modes or more memory based instructions. Here, more register based instructions. Second point, fixed length, that is 32-bit instructions. In the RISC architectures, all the instructions are of a fixed length, 32-bit. Whereas when you consider your CISC or Intel processors, mostly there are different lengths of instruction, that is 1 byte instruction, 2 byte instruction, 3 byte, 4 byte, and so on. But all these instructions are fixed length. Another most or very important point in the ARM architecture is it has an orthogonal instruction set. As far as ISA is concerned, instruction set architecture is concerned, it has orthogonal instruction set. What is the meaning of orthogonal set instruction? Orthogonal means all the instructions are applicable to all the registers. So when we consider the ISA instruction set architecture, ISA. So when you consider this ISA instruction set architecture, what is the importance of this instruction set architecture? It is always orthogonal. That means any instruction can be executed on any register, unlike your Intel processor. When you consider the Intel processor, in my earlier videos I have told you, normal microprocessors, majority of the instructions work only on accumulator. If the data is not in the accumulator, in the first stage you have to move the data operand into accumulator, then only it must be. Whereas in the case of ARM processors, there is no concept like accumulator. It's not accumulator based concept. It is orthogonal instruction set. So all the suppose there are 32 registers, all are 32-bit. Any instruction can work on any. Therefore, due to this orthogonal instruction set, the time is saved. You need not worry about the time of execution. So no wastage of time. That's another most important thing related to this ISA. Next important thing is this ARM architecture has conditional execution of instructions. This is not available in Intel processors normally. That means there will be always, it will check always a condition. For example, and if the condition is true, then only it will execute. Otherwise, that instruction will become no operation. That means there will be no wastage of time. Let us take an example. Add any R1, R2, R3. What is the meaning of this? Add if not equal R1, R2, R3. So you have three registers here. So you add the registers R2, R3. You add the contents of the 32-bit registers R2, R3. If they are not equal, you add them. And after this, you keep the result in R1. This is called conditional execution of instructions. This is not normally available in normal CISC processors. So therefore, what is advantage of this? That means whenever you don't require, you can stop executing the instructions. That means it can save time because that instruction will become no operation. That means simply it acts like a small delay instruction. Now, as I have earlier told, most of the instructions of the ARM are register based. Therefore, time of execution is minimum. Here I have given, when you want to access the hard disk, you take nearly milliseconds order of time, and the primary like SRAM etc. they will take microseconds. Primary memories, of course, you call this a secondary memory, and the registers and register files, set of registers, nothing but it forms a file, register file. They take nanoseconds of time. Very, very, very important. So once is nanoseconds means the time is reduced very much. So these are all architectural features of ARM which makes them high efficient and low power dissipation. So once you understand these things, another most important features of this regarding the instructions, it will have as you have seen in the name ARM 7TDMI, M multiplier, fast multiplier. So to improve the speed of multiplication especially, so it has any inline barrel shifter to process one of the input register. That is, it has an input barrel shifter. That means it shifts the data which helps in the fast multiplication, otherwise multiplication and accumulate operation MAC. So this is very widely used in digital signal processor applications. Digital signal processing applications. MAC means multiply, accumulate. So not only the multiplication operation is faster, it also performs multiply and accumulate operation, which is very widely used in designing the digital filters in your signal processing applications. So the simplicity of the architecture, both ISA as well as hardware architecture of this ARM processors, reduces the overhead, that is the burden on due to this each instruction, and allows the clock cycles to be shortened, means reduced. So these interesting features make these ARM processors to execute the instructions in lesser time, lesser clock cycles means lesser time, so that it can safely, it can happily execute the instructions at a higher speed with a reduced power dissipation. Hence, the ARM processor is considered as the most suitable candidate for embedded applications or mobile applications or any other recent consumer electronic products. I hope you have understood the basics of this ARM processor. In the coming videos, I will try to explain you the detailed architectures and other instructions, etc. Thank you for watching. Happy learning. Wish you good luck.